Here it is said a point source of light B is placed at a distance L in front of the center of a mirror of width D hung vertically on a wall. A man walks in front of the mirror along a line parallel to the mirror at a distance 2L from it as shown. The greatest distance over which he can see the image of the light source in the mirror is, and the corresponding picture is drawn here. It is given in the question, and we are having four different options. See, what actually we have to find is, let me assume the distance should be measured from this point, right? Okay, so I measure the distance from this point. This is my reference, and there is a man who is walking along this line in this direction, right? So he is walking like this along this line, and this is the mirror of width D, and this is the pointed light source whose distance from the mirror is L, and the man who is walking parallel to the mirror is at a distance 2L from the mirror, which is said here. For this, what we have to find is the person who is walking along this line must watch this pointed light source reflected from the mirror for a long distance. So how far he is able to watch this light source which is reflected from the mirror. So as he moves along this line, so he watches this pointed light source as a reflected light. Say, for example, if we treat the light is coming from this one and hits somewhere here, and we must know the reflected light source, I mean light ray, should come back like this. Okay, so this is the way how the light behaves. So light reflects, and when the person comes to this point, so definitely he watches the pointed light source. Now the question is how far along this line he is able to watch this light. For this situation, I drawn such a picture which simply resembles that the maximum position for which he is able to watch. So maximum distance. Okay, so maximum distance. So which is here, and measured from this point. Okay, so from this point, which is exactly opposite to the mirror at this end. So from here to here, so what distance from point A to this maximum distance, what should be the distance? So this is what we have to find, the maximum distance. Let me draw a line which is representing the midline, which is perpendicular to the mirror here. Okay, so this is exactly at the mid. So midpoint line, exactly at the midway of the mirror. Okay, of the mirror. So which is here. Okay, so mirror is here, and exactly the midpoint of the mirror is here, and I drawn such a line which is the midway line. Well, so I'm assuming the bulb is here, so this is the pointed light source now for me, and the light that reflects just at the edge of this mirror is reflecting here. Okay, so light is reflecting at the edge of the mirror and reflecting here, and for such a light ray, so the person can able to see the reflected light from the source, I mean mirror. So now knowing all this geometry, now angle theta is represented here, so this is my convention, and same angle comes here and here also. So look into this small triangle. So in this small triangle, what I can say is, so from this triangle, okay, so from this triangle, what I can write is tan theta is equal to, so this is, the width of this, that is opposite to this angle theta, is this much. Okay, so only this portion, so I have to consider this much. So this is d by 2, right? So that is d by 2 and divided by the adjacent segment. So adjacent is of length L. So this is definitely d divided by 2L. And now for this triangle, the angle is again theta for this. I call y somewhere here from this edge to this. So this is y I am calling. So tan theta is right. So not here. I rewrite it. Uh, 1 minute. I am rewriting. Tan theta is opposite is y. So theta is here, and in this triangle we are looking. Okay. So opposite is here, and adjacent is this one. So this is of length 12. So now equating these two, this is also tan theta and this is also tan theta, right? So now what I can write is uh, equating those two, it is y divided by 2l, which is equals d divided by 2l. So which implies y is equals d. So y is equals d means this width is d. Okay. What actually we have to find? We have to find the total distance from this point to this point, right? From this point to this point. So in that scenario, so from here to here, right? From here to here, I have to add distance d and this distance also. So this total distance is how much? Which is d, which is equal to width of the mirror. Therefore, needed distance, right? So needed distance is equal to y plus d. So that is y is what? D plus d, so which is equals to d. So this is the answer. So from this drawing, what we can obtain? So we need the distance from point A to this maximum distance. So that is it is y plus d. So this is 2d. So let us check which option is correctly saying this. So among these options, definitely option C goes right.